is the 16? X squared minus 4. So notice before I do any factoring or anything, the first thing I'm going to do is get a common denominator. X squared minus x minus 2 minus 6x squared plus 24. That look right? Any questions about that so far? I am going to factor the denominator. I'm going to hold off on factoring that numerator for two reasons. One, it looks pretty challenging, and two, I'm not sure. We'll see what we need to figure out on that. Okay, so from there, I'm going to answer domain, vertical, and horizontal asymptotes, and I'm going to go ahead and answer holes as well. So what is the domain? Very good. Any questions about why? Then, hold that thought. Second question is vertical asymptotes and holes, right? And this is something I haven't talked about a lot, but I want to teach you a shortcut. If the top happens to be particularly nasty or unfactorable at all, I want to decide whether, really the only reason I factor the numerator is to tell whether 2 and -2 are holes or asymptotes, right? What's a quick way to tell if 2 and -2 are factors at the top without factoring it? Graph it, plug it in. Could I just plug 2 and -2 into the top? If I get 0, then it would be a hole, and if I don't get 0, it'd be a vertical asymptote. Does that make sense? So if you come to one that you have a hard time factoring or can't factor, is this one not factorable? Has anyone checked it? 5x plus 11 and -x plus 2. I probably would have factored out a -1 and got next -2 if we were doing it by hand. How did they factor that? Because I said obviously they didn't do it by hand. How do you think they did that? They plotted quad 3, right? Quad 3 will show you the factored form of a quadratic. Now, why do I want that negative factored out? That's a hole. If I were to plug in 2 into the numerator, I would have gotten 0 on top, which lets me know that's a hole. So my holes are x equals 2. My vertical asymptote, x equals -2. Any questions about that one? So that one was a tough one. Holes, last thing, horizontal asymptotes. I would go back up to unfactored form, the -5x squared over x squared minus 4. Right? The -5x squared over x squared. What is that for horizontal asymptote? Y equals -5. Make sure you do put y equals on those horizontal asymptotes and x equals on the vertical asymptotes. Okay, graphing. I'm going to put those things on paper. I have a vertical asymptote at -2. I have a horizontal asymptote at -5. So far, so good. And then I'm going to go in my calculator to figure out the rest. You can plot more points by hand, but I'm going to go in my calculator to figure out the rest. Is it down here and up here? Has anyone grabbed it yet? To avoid any mistakes, graph the very original before you got common denominators or anything. Why would I do that? Just in case I got a wrong common denominator or something like that, then I'll catch that in the graph. I'll go, oh, the third asymptote's wrong. What did I do? Or the whole's wrong. What did I do wrong? So go back to the original when you graph. Down, up. So it's up here, and down, and then at positive 2, when I go to graph that piece, what am I going to put at positive 2? Make sure the asymptotes are clearly marked. Make sure the hole is clearly marked. Make sure you approach those vertical lines. Put some arrows to indicate that you're doing it. Any questions about that one? Are we getting better at this? Okay, let's look at this one. Stephen, was this your question? One like this? Before I can actually start working this problem, there are two things I need to do. One, I need to deal with the 2x parentheses cubed, and 2, I need to flip the second fraction. So I'm going to do those two things. What does 2x cubed actually mean? Good. 2x times 2x times 2x, which is 8. And I'm going to multiply that by 6xy over 16x to the 4th z. Anything that's on the top can cancel with anything that's on the bottom. You can do that by multiplying first and then canceling, or you can cancel and then multiply. Both work great. I like to cancel before I multiply. That's the non-calculator background in me, because I wouldn't want to multiply 16 times 3 and 8 times 6 and then cancel. I'd rather cancel the 16 and the 8 and the 6 and the 3. But that's because I come from a non-calculator background. I teach a lot of classes where you can't use a calculator. With a calculator, it doesn't matter either way, whether you cancel after or before. So whatever works better for you. X to the 4th on top. Do you see that x to the 4th on top? Is there an x to the 4th on the bottom? Now, if there were only an x cubed, then you would cancel the x cubed, but you would be left with 1x on the bottom. But all of those x's cancel. There are no y's on the bottom. There are no z's on the top. So I'm going to be left with a y on top and a z cubed on the bottom. Now let's talk about the numbers. Again, if I were working this, I'm going to cancel this 8 with the 16, which leaves me at 2. And I'm going to cancel this 6 with the 3, which leaves a 2 on top. And I'm even going to go ahead and cancel those 2's out. So the only thing left is the y over z cubed, which is 8. Yes. So when I divided 8 by 8, I got 2. So I divided both of those by 8, and I divided both of these by 3. I pulled out a common factor. Now, the other option, if you don't like that, is to have written this as 48y over 16 times 3 is 48. 48? You see why I don't do this way? You know, in my head that's harder. 48 z cubed, and then you could cancel the 48's. So either way works.
So if you get
X on top.
If all three of those x's are different, how would they all cancel out?
Okay, so if I were to work this differently, I would have gotten 48y x to the 4th over x to the 4th on the bottom. Okay, so that's x cubed times x.
Okay.
and then they cancel. Now that being said, say you had x cubed over x, then that's going to cancel and leave you an x squared on the top, or yeah, one of the x's canceling. So you can cancel partial x's. You know, if it's x to the fourth and x squared, you can cancel 2 of those x's and leave 2 where the x to the fourth was. But this one they did all cancel out.
So we could do it the other way.
You can do it how, if you get the right answer. I heard other math teachers say, all's fair in love and math. You can do whatever you want, as long as you get the right answer. I don't care.
Yeah, so I think your answer is when you get say on top and 2 on bottom.
And it would be 5 over 1. Because you can take out a 5 or a 2 out of both. Yes. Numbers and x and y is the simplest one.
So I feel important here.
Right. Y'all are asking good questions. Do y'all feel like this is helping? Okay, so on this one, before I start, what's the first thing I need to do? Flip the second fraction. Do I need a common denominator on multiply divide? When's the only time you need common denominators? There you go. Okay, so I'm going to flip the second fraction and I'm going to start factoring. I'm going to go ahead and factor an x out of that. You could go ahead and do all of the factoring. I don't want to do too much in one step, but you could. Any questions so far? The top factors, and again, college algebra could be very different if you had a professor that took your calculator away, and a lot of college professors do that. But should you mess up a factoring problem with quad 3 in your hand? No, you hear me, Alex? You should never mess up a quadratic factoring problem with quad 3 in your hand, right? Because it will do it for you. So make sure if you need to pick up a calculator, you do. And that's a beautiful thing about Arkansas Tech. They don't take away your calculator. That's not true at every school. Okay, so that's the left-hand fraction. The right-hand fraction is x squared over x plus 2 times x minus 2.
You mean like take away your calculator?
They just only use it on certain tests and things. So college algebra is taught very differently at different schools. And even sometimes at the same school between 2 different professors, it can be very different. Because this class would be crazy different if you couldn't use a calculator all the time, as far as difficulty level. So you're getting a good deal. You get free college credit. That's crazy. Okay.
But they won't have it.
Do what?
They won't have it.
What else? Yeah. It's not going with. Okay. On top, I'm left with x cubed. Does everyone agree? Gotta be that one. And x minus 7 and x minus 2 on the bottom. Good? That one is D. So what you notice is I'm doing an example like all of the problems on your Ruby. Don't find this helpful? Like, how do we solve equations with fractions in them? Good. Get a common denominator, then ignore the denominators, right?
So x minus 2
Okay. What about the left one?
He 3.
Good. Any questions so far? Good. I get 6 minus 2x squared. What after that? Plus 4x.
Minus. No.
All over 3 times x minus 2, okay? Equals x squared minus 3x minus 2x plus 6 over 3 times x minus 2.
So x squared.
I can now ignore the denominators and start to combine like terms. And move everything that's on the left to the right. Is that okay to do that in one step? So I get 0 equals the 2x plus c. 2x squared plus x squared is 3x squared. I added the 2x over. So this is 1 plus 2.
That's an equal sign.
There is an equal sign. 4x. So this is 5, negative 5x minus 4x gives you negative 9x. Good so far? And then positive 6 and positive 6. What happens when I subtract 6 from both sides? Let's go away. So let me stall on that step because I probably combined too many steps there. Any questions on how I got the 0 on one side? Remember, I just ignored the denominators. Subtracted and got all of the like terms together. So I can factor out a 3x. And I get x equals 0 and 3. I do need to go back and check restrictions. What are the restrictions on this? What can x not be?
2.
X just can't be 2. So are these two okay?
Yeah.
So whenever you got the 5
Answer.
Here, negative 5x. And minus.
on the first one, there is 3 acres. Is that negative 2 not 1? Not 1. Well, is that negative 2 not 1?
Negative 2, so I add 2x to both sides. So 2 plus the 1 is 1. That makes sense. Questions? What should you do on a problem like this on the test? What should I do? You should probably do. Yeah, but you should. What should I do on the test, as long as I have enough time, on every single solving problem? Check it. Plug the 3 and the 0 back into the top. And I've noticed some of you don't really know what I mean by that, so I'm going to show you that. Now, I'm going to do it up here just to show you what I'm doing. But do it in your calculator, right? Plug it in your calculator. So what I would do is I would plug in 0 in for x. So I get 2 over negative 2 minus 0 equals negative 3 over 3. Does negative 2 over 2 equal negative 3 over 3? What is negative 2 divided by 2? Negative 1. What's negative 3 over 3? Negative 1. Aren't they the same? So I did a good job. And then I would take the 3 and plug it in. I would get 2 over 1 minus 6 over 3 equals 0. Does 2 minus 6 thirds, which is also 2, equal 0? It works. I did a good job. On the test, check those answers. There's no reason to miss a solving problem, at least without knowing you're missing it. you should be able to find out that something you're doing wrong.
If you're like kind of split your time, can you just plug those in?
If it's multiple choice. Now, a lot of these will be open response, so you'll have to. And you also have the option of putting one side Y1 and one side Y2 and finding the intersection. Okay, another solving problem. Are there any questions? Do y'all have any questions, Ethan? Do you have a question or are you doing something else?
No. Still math related.
Just make sure you're kind of on your up here in case I start to mention something that you need to know. Okay, so what am I doing on this one? Before I do that, I need to make sure that x squared plus x minus 12 factors into those things. I hope it does. I think that's what you're assuming, but I better factor that first. Everyone agree? And so Alex is right. If that truly does factor into x plus 4 and x minus 3, then the very left-hand fraction needs an x plus 4. The middle fraction needs an x minus 3. Remember to be very careful on this middle fraction. Make sure that negative goes with everything in the numerator. So I get 5x plus 20 minus 3x plus 9 equals x squared plus 5. The fraction on the right already had a big denominator, so we didn't have to do anything to it. Any questions so far? Combine like terms. Get 0 on one side since it's a quadratic. Someone answer that for me.
Because the negative goes to the 3.
So you distribute this negative 3 to both pieces. And negative 3 times negative 3 is positive 9. 24. Factors of 24 that subtract to give you 2. So x equals 6 and negative 4, right? 10 equals negative 4. So it only equals 6. Did everyone see why? On the quiz, a lot of you missed that. You got x equals 3. You did everything so perfect. Got x equals 3 and forgot to say, no it doesn't. It can't. So make sure you say no solution or just the 6 if that's the case. Okay, any questions? I think I went through a problem with everyone on your review assignment. You still have about, 10, 20 minutes, 15, 20 minutes. So, work until the end of class. Tomorrow your review assignment's due.